To explore the effects on the graph of f of x equals to the absolute value of 2x minus 4. The first thing we're going to do is create a table where I'm going to let x equal to 0. And I'm going to determine the value of f of x. I will also let x be positive values. 1, 2, 3, 4. I will also let x have negative values. -1, -2, -3, and -4. If I substitute for x 2 times 0 minus 4, the absolute value of 0 minus 4 tells us that the f of 0 is equal to -4. That gives me the point 0, -4. I continue the same process of substituting the x values to determine the f of that x value. The absolute value of 2 minus 4 is -2. So when x is 1, y is -2. Two times 2 is 4. The absolute value of 4 is positive 4 minus 4 is 0. 2 times 3 is 6. The absolute value of 6 minus 4 gives us 2. One more positive value. 2 times 4 is 8. The absolute value of 8 is 8 minus 4. 8 minus 4 gives us 4. We do the same thing with the negative values. 2 times -1 is -2, but the absolute value of -2 is 2, and 2 minus 4 is -2. Notice we have a pattern here. 2 times -2 is -4, and the absolute value of -4 is positive 4. 4 minus 4 is 0. 2 times negative 3 is negative 6. The absolute value of negative 6 is 6. And 6 minus 6 is, 4. The absolute value of negative 6 is 6. And 6 minus 4 is 2. Two times negative 4 is negative 8. The absolute value of negative 8 is positive 8. And 8 minus 4 is 4. Now I'm going to take those three portions and graph them. I'm going to draw my vertical axis. So I'm going to substitute some of these points. We've got the point 0, negative 4. The points 1, negative 2. The point 2, 0. The point 3, 2. And the point 4, 4. I will connect those points using a straight edge. Now I'm going to look at the other side. So we've got the points negative 1, comma, negative 2. We've got the points negative 2, 0. We've got the point negative 3, 2. And the points negative 4, 4. I will connect those points. So let's describe its shape. The shape of this graph is in the form of a V. Just like our previous absolute value function, the parent function of absolute value functions. Our domain are x values, are real numbers, all real numbers from negative infinity to positive infinity. Our range has changed though. The range is no longer the same as a parent function. It has translated downwards. As a matter of fact, it's translated downwards 4 units. So the range goes from -4 to positive infinity. The intercepts are at x equal to 2, x equal to -2, and f of x equal to -4. Now, where is this function not defined? Where does it not exist? It does not exist when below this point. It is not defined. At f of x is less than -4. If we compare this function that we currently have to the parent function, if you remember, the parent function went through the point 1, 1, 2, 2, 3, 3, 4, 4. Two things happened to this graph. The green graph is f of x equals to the absolute value of x. Two things happen to it. The first thing that happens to it, if you notice, this point right here translated down 4 units. So transformation is translated 4 units down vertically, downwards. From f of x equals to the absolute value of x. So that was one transformation. It got pushed downwards, vertically down 4 units. But also, instead of going 1 up and 1 to the right, now it's going 2 up and 1 to the right. It's going 2 up and 1 down. So what we have here, if you notice, it got stretched. So the other transformation is a vertical stretch by a scale factor of 2 units.